Welcome my students. We have learned about refraction in the last class. Now our discussion is about the lens. There are two types of lens, convex lens and concave lens. Now you have to know what is a lens. Lens is a refractive medium. It is a refractive medium made of either two spherical surfaces. There is one spherical surface and there is another spherical surface. This is a lens, say L1, L2. There is one spherical surface L1, L2 on the left side and L1, L2 on the right side. So lens is a refractive medium which is bounded by two spherical surfaces and either by two spherical surfaces or one spherical surface and one plane surface. Now our discussion is about convex lens. Convex lens has a thicker mid portion and thinner edges. See, the mid portion is thicker and the edges are thinner. This is a convex lens and we will discuss about the concave lens later on. In that case, the convex lens, there will be thinner mid portion and thicker edges. If we compare, see, this lens L3, L4 has a thinner mid portion and thicker edges. So just opposite to convex lens. Now I discuss about the convex lens. Convex lens is also called a convergent lens. What is the reason behind stating it as convergent lens? Because if a parallel beam of light, parallel beam of light, take entry in the convex lens and after refraction it converges at a point. This point is focused. As the convex lens has got the capacity of converging a parallel beam of light at a point, therefore it is also called convergent lens. Now we have to know what is the principal axis. In this lens L1, L2, the principal axis is X, Y. The line X, Y, it is an infinite line. It is the principal axis. Principal axis is a straight line which passes through the center of curvature of the lens. Now what is the center of curvature? A lens, you see, is bounded by two spherical surfaces. This spherical surface is a part of this here and this spherical surface is also a part of here. Now this sphere has a center and this sphere has also a center. Say this center is C1 and this center is C2. So these centers are called the centers of curvature. So what are the centers of curvature? The centers of the spherical surfaces are called centers of curvature of a lens. Now if you join the centers of curvature, a straight line, this is an infinite straight line, C1, C2, the line passes through C1, C2. This is called principal axis. So the line joining the centers of curvature is called principal axis. Now principal axis is the main factor of a lens. Now you see, you have learned the principal axis. In this lens L1, L2, XY is the principal axis of the lens L1. A beam of light parallel to the principal axis here, this light, this way, this way, this way. A bunch of rays is called beam. So this beam of light is parallel to principal axis. If they are parallel to principal axis, then after refraction, they take entry in the lens and get refracted, and after refraction, they converge at a point A. they will converge at a point on the principal axis. But if the rays of light is not parallel to principal axis, say this is the principal axis and the rays, and after diffraction they will converge at a point outside the principal axis, you must give arrow for seeing the or observing the direction of the light. Without arrow, the direction of light will not be shown. So for showing direction of light, you have to use arrow. So this is also a point on which the rays of light converge. But this beam of light is not parallel to the principal axis here. Now, what is the reason behind this converging the light at the point? A lens, convex lens here, can be divided into so many prisms. A lens is made of innumerable number of prisms, and when the rays of light take entry in a prism, then they always bend towards the base. This is a ray of light. After diffraction, it will bend towards the base. In a prism, it will bend towards the base. In this case, the base of the prism is upward, so the rays of light will go upward. After diffraction, upward. Therefore, they will converge at a point, and this is the point of converging. This is why a convex lens is also called converging. Now, we will discuss about the focus of a lens. What is the focus or principal focus of a lens? A beam of light, if the beam of light is parallel to principal axis, this beam of light is parallel to principal axis, then after refraction, they will converge at a point on the principal axis outside the lens. This fixed point is called principal focus or second principal focus of the convex lens. So, second principal focus or simply focus of a convex lens can be defined as a fixed point on the principal axis outside the lens at which a beam of light parallel to the principal axis converges after being refracted by the lens. This is called second principal focus. But if the beam of light is not parallel to principal axis in this figure, they are parallel to each other, but they are not parallel to principal axis. They will converge at a point. In this point is called secondary focus. This is secondary focus. So there may be so many secondary foci in the convex lens as the beam of light parallel may be different. So different secondary focus can be made by a convex lens. But principal focus is here the second principal focus. And this second principal focus may be first principal focus if a beam of light diverging from this point in this manner. A beam of light diverging from this point, they will be converted into parallel beam of light in this manner after getting refraction. Say, this is a convex lens. This is a point on which the beam of light diverges. After diffraction, they are converted into parallel beam, parallel to the principal axis. Then this point is called first principal focus. So first principal focus is a fixed point on the principal axis outside the lens, from which a divergent beam, after getting refracted by the lens, convex lens, is converted into parallel beam. Then this point is called first principal focus. But traditionally, second principal focus is known as the focus. This second principal focus is known as the focus of the convex lens. Now we will go to the optical center. We have already learned the definition of center of curvature, principal focus, and principal axis of a convex lens. Now, one of the main criteria, one of the main definition of optical center. Optical center is a peak point on the principal axis. Here, the convex lens L1, L2, and it is O is a peak point on the principal axis inside the lens. If a ray of light passes through this point, it travels undeviated without occurring any refraction along a straight line path. This is a ray of light, say XY is a ray of light. This ray of light is an incident and passes through the point O without occurring any refraction. So O is the optical center of the convex lens L1. So optical center of a convex lens can be defined as a fixed point on the principal axis inside the lens through which a ray of light passes undeviated without occurring any refraction along a straight line path. It is the optical center of a thin convex lens, and a convex lens has only one optical center. It can be considered as the midpoint or center of the lens. Now for thick convex lens, the optical center will be changed. But for a thick convex lens, optical center, this optical center O as a fixed point on the principal axis inside the lens, after passing through which a ray of light is converted into parallel ray to the incident. The optical center of a thick convex lens can be defined as a fixed point on the principal axis inside the lens, after passing through which a ray of light emits parallel to the incident ray. In case of thin convex lens, this incident ray and refracted ray becomes one, that is, the ray passes undeviated. So this is about the optical center of a convex lens. So what we have learned, number one, we have learned the definition of center of curvature. How many centers of curvature are there? There are two centers of curvature because a lens has two spherical surfaces. Question may be asked, if there is only one spherical surface and one plane surface, say this is a spherical surface and one plane surface, no conflict. In this case, we will get one center of curvature. So this is the sphere by which this spherical surface is made. This is the center of curvature. And for the plane surface, the center of curvature will be situated at an infinite distance. The center of curvature will be at infinity. This is about center of curvature. And then we have learned principal axis. Principal axis is the straight line passes through the center of curvature. Then we have learned principal focus. And then optical center. Principal focus, definition of principal focus will be different for concave lens. Now we have, for the first instance, completed the convex lens, that is different definitions of different terms related to convex lens and the nature of convex lens. The formation of image by a convex lens will be discussed later. Thank you, my students.
For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.